Let's practice one more integration by parts problem. Here we have x3x dx. Let's look at the functions. The first function is x, which is algebraic function, and the second function is 3x, which is exponential function. So algebraic comes first. That means our u would be x, and the remaining portion, this 3x dx, becomes dv. For the u, we need to differentiate. Du would be x's derivative is 1, just dx. For dv, we need to integrate. We will get v is equal to, do you guys remember? The integral of ax dx was ax by natural log of a. This was the formula which we learned in our exponential integral. So this would be 3 the power x by natural log of 3 in this case. Don't write c here in the integration by parts area. Okay. Now remember our rule for integration. U dv is equal to uv minus integral v du. Let's write that down. Using that, our integral be equal to uv. U is x, v is this, so u x times this minus integral of v is 3x natural log of 3 constant, so I'm going to write it down. Du is just dx. Now one important point, this was a definite integral problem, and this part we already integrated. Okay, so that means here you're going to write limits like this, and we're going to continue writing limits in the integral of the second part of the statement. Okay, so for the first part, you can get ready to put the limits. So when I put 1, it's 1 times 3 power 1 by natural log of 3 minus, this will be just 0 when I put 0, minus 1 by natural log of 3 integration of 3x using the formula would be 3x by natural log of 3 again. But again, we have the limits. We'll put the limits here. Don't write c here because it's a definite integral. You do not write c when it's a definite integral. Okay. So from the first one, I'm just getting 3 by natural log of 3 minus 1 by natural log of 3. Now because of the definite integral, I need to put limits in. When I put 1, 3 to the power 1 is just 3 by natural log of 3. Minus when I put 0, 3 to the power 0 by natural log of 3. Okay. 3 by natural log of 3 minus, when this thing multiplies inside, 3 times natural log of 3 square, and when this multiplies inside, this is only just 1, please remember. So that's minus minus plus 1 by natural log of 3 square. These two, they both have natural log of 3 in the square at the denominator. So basically 3 by natural log of 3 minus 2 by natural log of 3 square. These two together will make negative 3 plus 1 will be 2. That should be your answer. Let's look at another example. Arc sine x dx. First of all, as you know, I don't like to like arc sine. Arc sine simply means sine inverse of x dx. Now, all the questions we have been doing for integration by parts, they have two functions, like it's kind of an other part of product rule, if you want to say like that. So there has to be two functions, but in this function there's only one function. So I'm gonna manipulate another function here by writing 1. Okay, 1 multiplies with everything is just same thing, so it doesn't really change the question. Now we have two functions, so let's look at the two functions. Sine inverse x is an inverse trigonometric function, so that comes first in the list. And 1 is basically algebraic function. Okay, so I comes first. That means I'm going to name u as sine inverse function because that's an inverse trigonometric function that comes first in my Li8 mnemonic list. And the second function 1, which joined with dx, I'm going to name that dv. Okay, that's the first step to come up with u and v. The u we are going to differentiate. What's the derivative of sine inverse x? That's 1 minus x square root in the denominator. You always need to write dx. And for the dv, you need to integrate. What is the integral of 1? So v, integral of dv is v. Integral of 1 is just x. Okay. Let's write down our formula. Integral u dv is equal to uv minus integral v du. That is your integration by parts formula. Using that, we can name our question, which is sine inverse x dx. Now we have made it u dv using our function is equal to uv. What is u? Sine inverse x times v. I'm going to write just in the front. Minus integral v. V is x times du. Du is this whole thing. So this is what I am getting. Okay. Now the first part is done. X sine inverse x. For the second part, how do we solve that integral? Okay, I think this calls for substitution. Okay, if you notice, 1 minus x squared is in the denominator, x is in the numerator. 1 minus x squared's kind of derivative is staying there. So I'm gonna assume, so forget about the previous u here. For this part, we need substitution method, u sub method. So I'm going to say u is 1 minus x squared here. Okay. Then what is du? Negative 2x dx. We already have x dx in the question. So x dx would be equal to negative du by 2. So let's make our substitution. Integral x dx is negative du by 2. So 1 by 2 will come out. And 1 by root. This 1 minus x square can be substituted as u. Okay. X sine inverse x. This part is already done. Don't do anything to it. Just copy it. 1 by 2. This root u can be written as negative half because it was in the denominator. That's why it's negative. And root, that means it's 1 by 2 power. X sine inverse x is equal to half power rule. Do you guys remember the power rule? Integral xn dx is what? Power add 1 divided by new power plus c. That power rule will make this u the power negative half plus 1 by negative half plus 1 plus c. Let's simplify all that. X sine inverse x plus half u the power half by half plus c. This 2 will just cancel with this. X sine inverse x plus this u here is 1 minus x square plus c. That is your answer. I just want to make sure that you guys understand that I just took u because you are so used to doing the u sub, but this u part and this u part is different, okay? So here is another example of a question called arc sine x. There is no direct formula to integrate sine inverse x. So this is the method. You can do arctangent like this. You can do arc cosine x like that using integration by parts.